Okay, in this next problem, we are going to be summing up, it looks like, two squares. I don't know. Let's see what it says here. The sum of squares of two consecutive positive integers is 25. The sum of the squares. Let's do an example. Let's do, they're two consecutive. Yeah. Two consecutive. Let's say, for example, we have, oh my gosh. Am I ever going to learn on this? Probably not. All right, example quickly now. What about 5 squared plus 6 squared? You see, that's the sum of two consecutive squares. Okay, so that'd be 25 plus 36, whatever that is. All right, so that just gives you an example of what we're doing here. Example, what we're going to be looking for. Okay. All right. They must sum to 25. We'll let the first square just be x, and then the second square, since they're consecutive, we'll let it be x plus 1. Okay. All right. So x squared, that will be our first square, plus x plus 1. And that'll be our second square, is equal to 25. Is equal to 25. So now we've set our equation up, and now we want to solve for x. So what we're going to want to do is get this thing looking like that quadratic, the quadratic equation, and we want to write it in standard form. So it looks like what we're going to need to do is multiply this one out for sure. I'm going to work a different color, so I'm going to get this mixed up. Let's do this. Because there's two of them, we can write it like this: x plus 1 times x plus 1. Okay, that's been expanded out. Now we're going to want to multiply. So let's do that. So we have x times x, and then x times 1, that's x squared, plus x. 1 times x is x, and then 1 times 1 is 1. Okay, so that all simplifies down to x squared plus 2x plus 1. Okay. So that's going to be this stuff now. So let's go ahead and rewrite it. Actually, yeah, we simplified it. Let's go ahead and rewrite this. So we end up with x squared, right? That's this guy. And now we're going to write this one that we expanded out, plus, which is all of this, x squared plus 2x plus 1. Hold on, we're not done. Right, we still have this part here to write. Is equal to 25. Okay, let's go ahead now and simplify this down a little bit. We have some like terms. We have an x squared, so that's going to make that 2x squared. We have a 2x, so nothing like there. And what I'm going to do now is I'm going to go ahead and take this 25 over here to the left. So that's going to make that a minus 25. I guess we'll have to write this one more time. Get it that quadratic equation form, in standard form that is. Right, 1 minus 25 is minus 24. Got ahead of myself on that. Okay, so now the next order of business is going to be we want to solve for x. So we got to factor this thing. But if you notice that when we go to factor a quadratic equation, we want to make sure first off that the coefficient out here in front of x is positive. We also want to make sure that there's not a number that goes in both this coefficient in front of x squared, the coefficient in front of x, and then the constant here, 24. And of course, this case, 2 does divide evenly into all three of them. So what we'll want to do is factor that 2 out. So let's do that. Let's factor the 2 out. Rewrite. And 2 goes into 24. That'll be 12 times. All right, rewriting equal to 0. And now what we can do is go ahead and factor what's in parentheses here. So two numbers that multiply together gives us 12, and when we add them, we get positive 1. That's that coefficient that's out here in front of x that we can't see. All right, that we don't write. Okay, so let's rewrite. Write everything that we know here that we're going to be writing. Okay, so what did I say? What about 3 and 4? We know 3 and 4 is close together because we need to get a positive 1 in here. So 3 and 4. Whoops, I forgot to write an x there. All right, since it's a positive 1, the larger number, there'll have to be a plus sign out in front of it, and then minus. So negative 3 times positive 4 is negative 12, and when we add them, negative 3 plus positive 4, we get a 1. So there you go. Okay, and I've run out of room. So what we do is just set this factor here equal to 0. Obviously, you can see that it's going to be a 3. Right, set this factor. I mean, at this point, you should just be able to look at it and tell, but right, so x, let's use a different color. If we plugged a 3 in there, we get 3 minus 3 is 0, so we know one of the solutions is 3. And if we plugged a negative 4 into this one, we know that the other solution, right, is going to be negative 4, obviously. Negative 4 plus 4 is 0. Okay. So what do we got? 3 and 4. It looks to me like we would, so the 3 here that we plug in, let's go back up. See this right here? It says positive integers. So we can't use the negative 4, but what we can use is the positive 3. So 3, and then 3 plus 1 is 4. There. Okay, the sum of two squares. So what would those sum of two squares be? They would be 9 and 12. 3 squared is 9. 4 squared, or 4 squared is 16. So that'd be 12 and 16. But anyway, the two consecutive positive integers, 3 and 4. All right, well, that pretty much ends this session. We got lots more problems to work in the applications. I think we're working on a, what are we working on next? A rectangle, something like that, in the next problem. Okay, see you in the next problem.